Dear conference participants, in today's education landscape, gamification, the integration of game elements into learning environments, has emerged as a powerful tool to enhance engagement, collaboration, and knowledge retention. By incorporating mechanics like points, badges, and leaderboards, gamification transforms learning into an exciting and memorable experience, fostering positive attitudes towards education. It nurtures essential life skills, motivates students, and aligns with younger generations' preferences for interactive and instant experiences. While offering transformative benefits, challenges such as digital divides and attention spans must be addressed through a balanced approach that combines gamification with traditional methods. Leveraging popular computer games like Minecraft Education Edition can create immersive and customizable learning environments that foster collaboration, creativity, and interdisciplinary learning, ultimately revolutionizing education for students of all backgrounds and learning styles. Minecraft Education Edition revolutionizes learning by seamlessly integrating gameplay with educational content. Tailored specifically for classrooms, it offers a dynamic platform where students can explore, create, and collaborate across various subjects. Its block-based coding interface serves as a gateway to computational thinking and problem-solving skills, making it accessible and engaging for learners of all levels. Beyond coding, Minecraft Education Edition incorporates key concepts from mathematics, science, social studies, and more into its immersive gameplay, fostering interdisciplinary learning and deeper understanding. Teachers can customize experiences to meet specific learning objectives and accommodate diverse learning styles, while also promoting teamwork and creativity. By leveraging the limitless potential of Minecraft Education Edition, educators can cultivate a passion for learning and equip students with essential skills for success in the digital age. The introduction of educational moments into Minecraft led to the development of Minecraft Education, a separate version specifically designed for educational settings. Over 400 schools across the USA, Europe, India, and Scandinavia currently utilize this game in their curricula. Its versatility and user-friendliness enable its application across a wide range of elementary school subjects, including mathematics, chemistry, physics, biology, and literature. The purpose of the study: to study the possibilities of integrating the content of the educational program from Informatics Programming Workshop of training future informatics teachers in a higher educational institution to the game process of learning Minecraft. Research objectives: 1. To consider the peculiarities and possibilities of Minecraft training in relation to the gamification of the educational process in this educational discipline. 2. To offer effective ways of integrating individual topics from the programming practice into the Minecraft gameplay. 3. Develop and implement tasks, projects, and creative tasks. 4. Perform a research experimental check of the methodology of integration of programming learning into the Minecraft gameplay. The study employs an experimental design with a control group and an experimental group, each consisting of 12 students. The control group receives traditional programming instruction, while the experimental group engages in programming tasks within the Minecraft environment. The experimental verification involves collecting data on student performance and learning outcomes. This includes assessing students' ability to develop programs to solve standard problems from the curriculum's topics, as well as measuring their engagement and understanding of programming concepts. A specialized test utilizing the system of automated verification of problems on the website eolymp.com is used as the measuring tool. This test evaluates students' programming skills and knowledge by requiring them to develop programs to solve predefined problems. The effectiveness of integrating programming learning into Minecraft gameplay is analyzed using the non-parametric Mann-Whitney test. This statistical analysis compares the performance of the control group and the experimental group to determine if there are significant differences in learning outcomes. In our study, the curriculum was developed for the disciplines Informatics Programming Practicum of the Secondary Education Informatics educational program with the integration of learning into the Minecraft gameplay. Let us present the characteristics of the discipline. The subject of study is the practical mastering of the basics of programming, using the language of modern programming languages, using the Python language as an example. In the first lesson, we explain to students what Minecraft education is and how it is used in education. We show students who are not familiar with the game how to play. We give students the opportunity to play Minecraft education so they can learn the basics of the game. Consider the installation and configuration of the game, Java, the necessary mods. We offer them interesting tasks that lead them to think about the effectiveness of using framing in the Minecraft education gameplay. We use various resources to introduce students to Minecraft education, such as websites, videos, and tutorials. Examples with rapid construction especially impress students. They are convinced by their own experience that the ability to program is a skill that gives an undeniable advantage over players who do not know how to program. We encourage such students to use Python to create mods or plugins for Minecraft. This is a more difficult task, but it can also be very rewarding. Mods and plugins can add new features to the game, such as new blocks, items, or game mechanics. The experimental verification of the results of the implementation of the specified integrated gaming curriculum in programming was carried out in the control group, 12 students, and the experimental group, 12 students. The measuring tool was a special test using the system of automated verification of problems on the website https://www.eolympy.com, which consisted in the development of programs for solving standard problems from the topics of the curriculum. 10 standard tasks were proposed for each topic according. The control group received instruction on programming concepts relevant to informatics teaching through standard academic channels, without the incorporation of gamified elements like Minecraft. Their learning experiences may have been more structured, with a focus on theoretical understanding and technical skill development in a controlled, non-game environment. In contrast, the experimental group experienced a more innovative approach to learning, integrating Minecraft as a platform for exploring and applying programming concepts. This group would have engaged in activities specifically designed to leverage the gamification features of Minecraft to reinforce their understanding of programming principles. Because the sample sizes are small and they suspect that the sample distribution is not normal, we decided to perform the Mann-Whitney U test to determine whether there is a statistically significant difference between the test scores of the control and experimental groups. Mann-Whitney U test is 28. The critical value of the Mann-Whitney U test for a given number of compared groups is 37. 28, 37, therefore the differences in the level of the trait in the compared groups are statistically significant. P 0.05. Hypothesis: H0 is rejected at the significance level of 0.05 or 5%. This indicates that the scores in the control group are systematically lower than in the experimental group. Research experimental verification of the developed methodology for integrating the curriculum of the discipline. Informatics Programming Practicum into the Minecraft game process proved its effectiveness and is recommended for implementation in the educational process. The study underscores the potential of integrating educational content into popular gaming platforms like Minecraft to enhance learning outcomes, particularly in challenging subjects such as programming. The findings of the study demonstrate that by leveraging the immersive and interactive nature of Minecraft, educators can effectively engage students in learning complex programming concepts. The experimental verification of integrating programming curriculum content into Minecraft gameplay confirms its efficacy in enhancing student understanding and retention of programming principles. In conclusion, the successful integration of programming curriculum content into Minecraft gameplay underscores the potential of gamified learning environments to revolutionize education. By leveraging the engaging and immersive qualities of popular games like Minecraft, educators can create dynamic and effective learning experiences that empower students to master complex subjects and prepare for future challenges in the field of computer science.